लाइव हो गया क्या? लाइव हो गया. Good evening, good evening, good evening, good evening. Good evening, guys, and a very, very, very happy new year to all of you. Yes, guys, this is my first class after the new year. This is my first class of 2021. This is the first time I am interacting with you guys in the year 2021, whether it is the YouTube or the special classes. And first of all, I am extremely sorry for that. There was some medical emergency with one of my family member, an elderly member. My grandfather, he was a bit down. So I apologize to all of you for that I could not take classes in the gap between. But guys, I will definitely make up for that. I promise each and every one of you that I will definitely make up for that. चलिए चलिए फटाफट फटाफट आ जाओ यार, आ जाओ आ जाओ आ जाओ. Come on guys, hurry up. Join fast. So, let's give a brief introduction of mine. So friends, my name is Manish Mishra. I secured an All India rank of 568 in GATE 2015, and since then I have been teaching for GATE and ESE because of my passion for teaching, and because after my success in GATE 2015, I thought that this is going to be the most appropriate field for me to work. Sir, please take daily class of operations research. Hare Ashwin, I know man, you have seen my classes in 2020. KR Thakur, Mukesh Sirvi, I think you guys used to watch my classes recorded, right? This is the first time I am seeing you guys live. So, nevertheless, so guys, since then I am teaching for GATE and ESE, and I have a cumulative experience of 5 years in teaching now. The subjects that I primarily take are manufacturing, industrial operations, as well as material science. So basically, if you will look at the subjects that I take, I basically cover the entire section 4 from the GATE syllabus of mechanical, right? And the section 4, my friend, it has a cumulative weightage of 25 marks, which is like 1/4 of the entire GATE paper, right? A very important area, but I must say a very easy area, a very easy domain. Okay? So guys, for those who do not know about this, let me just tell you, I started a series by the name of Manufacturing 2020, in which I targeted the entire manufacturing in just 20 days time by dedicating 120 minutes every day, which can help you guys fetch 20 marks in the GATE examination, right? So these classes are on Unacademy special classes. They are absolutely free. I started this series on the 10th of December, and now I am very close to end this series. I mean, hardly 1 or 2 classes left in which I will be completing this entire series, manufacturing plus material science plus metrology. So those of you who have not watched this, I would recommend you scan the QR code which is right behind my back once you will get the notes and PDF of this class, and go enjoy this session, right? Friends, if you want to watch my class, simply scan this QR code. This will guide you towards my profile page on the Unacademy app. I am a verified educator on the Unacademy platform, and I have a ranking of 95 among 1000 plus educators in the GATE and ESE category. Guys, I have achieved this in just 30 days time, and this would not have been possible without the love and affection of you guys. So thank you very much for this. And remember, if Unacademy prompts you to to unlock your free plan, because remember, the special classes of every educator is absolutely free. So if the Unacademy app prompt you to unlock your free plan, remember to use the referral code MMM10. This will unlock your free plan on the Unacademy app, and then my friends, you will be able to watch all the sessions, all the special classes of all the educators across any category on the Unacademy platform. So guys, if you want the notes, PDFs, practice booklets, and many more practice contents. Hi friends, classes, like and share please. I do not know what do you mean by that here, Shakar. So I was saying that if you want to have the notes, practice booklets, notification, guidance, and many more of my lectures, then join this Telegram group chat. This is a two-way channel, my friends, where you and I can discuss together whatever doubts and discussions you have. You can put up on the Telegram group chat and I will be answering them. Just simply scan this QR code and you will be able to join the Telegram group chat. So guys, now let us start the session without wasting any time. So industrial engineering operations research. So remember friends, I have completed everything on this series: linear programming problem, transportation problem, assignment problem, sequencing, queuing, project management, inventory model, forecasting, break-even analysis, line balancing, work study, production planning, control. These two topics are left: quality control and material resource planning, and today is that class. Today is that class, my friends, where I will be completing these two topics also. So, let's not waste any more time, because time is already very precious. 2021 has started. On the 14th of February 2021, you will have to write your GATE mechanical paper. So, let's start, my friends. Let's start this session. Good evening, Ankur. Good evening, Jhakar. Good evening, Ashwin. Good evening, Mukesh. A very good evening to all of you. Let's start this session straight away. So guys, first of all, let us understand what is statistical quality control. So before we do that, let us first understand what is statistical and what is quality control separately. So first of all, get an idea what is statistics. So the collection and the analysis of large quantities of information in the form of numerical is basically statistics. Right? Whenever we talk about statistics, hi Venkatesh, good evening. Welcome to the class. So statistics basically means you must have seen the cricket match, where they show the player statistics. So basically they have collected the data of that very player performing in the previous matches, and based on that data they provide you with the statistics. That this player like Virat Kohli, he has a batting average of this much, he has an economy of this much, as a bowler he has taken this much wicket, so basis of statistics is just data. Based on the data, we try to speculate certain things, right? I hope people are able to understand me, right? I hope people are able to understand me. Basic concept of forecasting, basic concept of speculation, basic concept of improvement depends on the entire game of data. So those data, the analytics of those data is called as statistics, right? Now what is quality control? What is quality control? I mean, I do not have to tell you what is quality. I do not have to tell you what is quality. Let me just tell you straight away. I mean, you must have seen a Mercedes Benz and you must have seen a Maruti. Both are cars. Right, even the Mercedes Benz C class can only sit 4 people, and even a good old Maruti Wagoner can sit 4 people, right? But you know what is the difference between a Mercedes and a Maruti, right? I hope you are getting my point. A Mercedes is an extremely well built machine with minimum friction, right? With extremely refined quality standards, and that's why it costs us around 50 lakh rupees to buy the cheapest of the Mercedes out there, and it will cost you like 2.5 or 3 lakh rupees to buy the cheapest of the Maruti. I hope you are getting my point, right? So both are cars. Basically, both have an internal combustion engine, both have suspension, both have a chassis, both have frames, seats, steering, the basic requirement which is there in a car is basically same. But you know what is the difference between a Mercedes and a Maruti, right? So quality control simply means a system of maintaining standards in manufactured products by testing a sample to see if it meets the required standards. So remember guys, controlling quality is different than quality. When I talk about Mercedes, I talk quality. But when I am talking about controlling quality, then basically, my friends, inside the Mercedes factory, the parameters that they have decided, according to which every Mercedes car should be manufactured, the specifications that they have created that every Mercedes car should fulfill, they are far better of higher standards as compared to a Maruti car. So meeting those standards, trying to meet those standards while manufacturing a Mercedes car is what we call as quality control. Controlling the quality of a product is called as quality control. So when I talk about statistical quality control, it simply means the use of statistics, the use of data to control the quality of manufactured goods is called as statistical quality control. So let's not waste any more time and jump ahead of this. So let me just provide you with the basic concept. Let me just provide you with the basic concept. Yes, Sonu, Happy New Year. Suppose guys, you must have seen like cars are out there on roads, right? So even the cheapest of the cars, they have like 5,000 to 7,000 parts. Even the cheapest of the car, even a Maruti Alto or a Tata Nano must have 5,000 to 7,000 parts, right? Now what happens? The manufacturer, let's say we talk about Tata Nano. Let's say we talk about Tata Nano. So Tata company that manufactures Nano, they do not manufacture all these 5,000 parts. Majority of these parts, they outsource. Outsource. What is the meaning of this word outsource? Right? What is the meaning of this word outsource? So guys, outsource simply means when you provide the license to manufacture your products to somebody else. Suppose you are a manufacturer who produces, let's say, tires. Now guys, you must have seen on every automobile out there, like there are 3-4 companies that basically manufacture good tires in this country, and they are Seat, MRF, Bridgestone, Michelin, JK tires. So these are 4-5 brands which are very reputed in the country, and any out there, any car you would see on the road, they basically would have a tire made out of any of these 4-5 companies. So if we talk about the tires of Tata Nano, so tires is one thing which Tata must have outsourced to one of these companies to manufacture, right? Now, like this, there are thousands and thousands of parts which Tata company basically outsource to other manufacturers so that they can manufacture those parts and they can ship that back to the Tata factory, and then Tata company or manufacturer will basically assemble all them together, inspect them properly, test them properly, and will finalize a proper finished product like a car, like a Tata Nano, and then they will sell it through their selling chain, marketing chain. Okay, so these outsourced parts, they are called as OEM, original equipment manufacturer, right? So if whenever you will go to a showroom, like you must have visited your two-wheeler showrooms, right? Hi sir, thank you so much sir for taking lots of efforts, sir. Love you sir. Thank you Gino, thank you so much my friend. So guys, I was saying like OEM basically means original equipment manufacturer, right? So you must have seen, you must have gone to your service center of your two-wheelers. If you have two-wheelers or if you have four-wheelers, you must have gone to the service center. So at the service station, they basically have the original equipments that are manufactured by either the manufacturing company or they are manufactured by another licensed company. Okay. Sir, what is quality of conformance? Arey Shubham, why are you hurrying up, man? We will get to know each and everything. But let me just help Shubham if he is not in the mood to study this entire lecture. Confirmation. Confirmation. The word confirmation means what? When I want to give you an answer in a yes or no. If you asking me, sir, can you please confirm me? I would say either yes or I would say either no. I hope you are getting my point. So conformance means conformity, confirmation, right? So whenever we have to check the quality in terms of a yes or no, ha ya na, then it is called as quality of conformance, right? Don't worry, I will discuss that later in my class. If you are doing something else, studying something else, you can do that, but you can join the lecture, let's say after 45 minutes, I might reach there by that point. Okay, so I was discussing original equipment manufacturer. Hai. So guys, I don't know whether you have experienced this or not, realized this or not. I mean, I have a Honda City car, hai, and I purchased the car back in 2017. So I purchased the car back in 2017. So in 2017, when I bought the car, so recently a couple of months back in the August or September month, the suspensions were completely wobbling. They were not in good condition. So what I did, my car was out of warranty. The company provided me a 2-year warranty. It collapsed in 2019. So I went to the showroom and I asked them that what is the issue with my car? It is wobbling, it is not like riding very smooth, and the bumps are, I mean, they are experienced inside the cabin of the car. So they inspected my car and they told me that, sir, your suspensions are completely gone. You need a complete, what do you say, renewal of the suspension. You need new suspension setups in all four wheels. So I asked them how much it will cost me. So they gave me an estimate that, sir, including labor and everything, GST and everything, this will cost you like 55,000 rupees. So I was like, oh my god, 55,000. I have a 3-year-old car and now 55,000 suddenly. So actually I drive very rashly. I go through all pots, holes and everything. So that's why my suspension worn out. I took the car on long drives also. In 3 years, like I have driven like 90,000 kilometers or something. So my suspensions were completely worn out. So it needed a change. So what I did, I asked them about the estimate. They gave me a 55,000 rupees estimate, but I didn't went with them. I go to a local mechanic. I went to a local mechanic. I saw that in his garage there were quite a number of cars standing. A friend of mine recommended his garage, so I went there. So he basically told me, sir, the complete suspension overhauling and everything renewal, new suspension setup, I will do it in 15,000. I didn't tell him that the company is asking me for 55,000 rupees. I just told him that car is not running well. So he said, yes, 15,000, complete new 4 suspensions. I was very happy. I thought the company is making a fool out of me. So he took the car and after like 7 or 8 days, he fixed my car, new suspension, 15,000 paid. I took the car home. Right now, just after 3-4 months, now currently basically now, the car rode well for 2-3 months, but now my friends, that suspension is like over. Nothing is left. I am again on the same zone where I was 4-5 months ago. I spent 15,000 rupees, but ultimately I ended up in the same situation I was. So I went back to the mechanic. I told him the suspensions are again like the same thing is happening with me. So he told, sir, ki we use the aftermarket parts. So aftermarket parts are basically those which are manufactured by other local manufacturers, but they are not original equipments. They are not licensed parts made by or manufactured by or licensed by a particular company who is making the product. So when I went to the parts shop and I basically asked them that how much the new suspensions of original equipment manufacturer suspensions of Honda City will cost, he basically told me it is 42,000. Right? So guys, remember, original equipments are original equipments. I am sharing this story with you guys so that you can get an idea that why a manufacturing company spends billions of dollars. Literally, they spent billions of dollars, right? I mean, in the research and development division of Honda, they must be spending somewhere around $1 billion or $2 billion so that they can come up with good products, quality products, and they manufacture each and everything with precision and quality. That is very, very important, right? So I was saying, suppose take a very basic example. Suppose Tata Nano has a shaft inside it. Tata Nano has a shaft inside it. Now this shaft, my friends, it is made of some specific material which must have some specific strength and other mechanical properties. But let's say we talk about only dimensions. Like the diameter of this shaft is, let's say, 25. The diameter of this shaft is 25 centimeter and the length of this shaft is 100 centimeter. Now this shaft is very important in the car, right? One end of this shaft goes inside, let's say, the engine, and the other end goes inside the gearbox. So it is a very important part. It is basically acting as a power transmission tool or a power transmission mechanism or shaft, right? So this shaft is highly important with respect to the Tata Nano car. Now Tata has outsourced this part and they are basically asking for 50,000 units of this particular shaft. 50,000 units of this particular shaft, which must have a diameter of 25 centimeter. Now guys, if Tata Motors will ask that they need 50,000 shafts of exactly 25 centimeter, I must tell you it would have been impossible to manufacture. Impossible to manufacture, right? If somebody is asking for 50,000 jobs with exact same dimension, then on the basis of manufacturing setups, on the basis of machine errors, human errors, and don't even know what kind of errors are there in manufacturing. It is basically impossible to manufacture 50,000 shafts with exact 25 centimeter diameter. We can do that. I'm not saying like it is impossible, humans cannot do this. Humans can do this. Humans can do everything. And we humans have achieved so much. So 50,000 shafts of exact 25 centimeter diameter is not impossible. But considering the cost of Tata Nano, and the quality standards that the manufacturer of this shaft will have to take care so that every shaft he achieves is of 25 centimeter diameter, my god, it would have been like really exhausting. So whenever they ask us to produce a large number of products of any dimension, they basically provide us with a tolerance. Now, what is a tolerance? Tolerance, my friend, is basically a range. So, Tata Motors will basically provide a range, है ना? So, where one will be called as the lower limit and one will be called as the upper limit. Lower limit and the upper limit. What is the meaning of this? So, basically, it means that Tata Motors will accept any shaft. Tata Motors will accept any shaft which will lie in this range. So if this manufacturer will produce shaft within this range from 24 to 26 centimeter, Tata Motors will buy this shaft. But if the manufacturer produces a shaft of, let's say, 27 centimeter or let's say 23 centimeter, which is not in this range, then these shafts will be rejected. How they will ensure that whether this manufacturer has produced 50,000 jobs or not? That we have already studied in metrology and inspection. Today I am not here to teach you metrology and inspection, my friend. I am here to teach you statistical quality control. Tata Tata Motors has provided us with this range of 24 to 26 centimeter, and this manufacturer who has been provided the license by the Tata Motors company to produce the shaft, he must be producing these shafts in this range, well defined in this range. Otherwise, he know that any sample, any lot under the inspection process, if it fails to fall in this category, they will simply reject it, they will not buy it, and it will be a factor of loss, of shame, of disgracefulness for this particular manufacturer. I hope you people are getting my point, Baba. I hope you people are getting my point, right? So guys, Tata Motors will send some engineers, inspection engineers, who will basically inspect whether these 50,000 shafts are in this range or not. But guys, that is not our concern. That we have already studied under metrology. If you want to watch that lecture, go check out my special classes. I have already made a lecture on metrology and inspection, right, with respect to the gate examination. So questions do come from this. Don't forget, questions do come from this in gate examination, metrology and inspection. But today we are not here to study metrology and inspection. We are here to study statistical quality control. So guys, focus, है ना? So this manufacturer, if he has to produce 50,000 shafts in this range, if he has to produce 50,000 shafts in this range, then basically, my friends, he will have to supervise the manufacturing facility. He will have to supervise the manufacturing facility, that whether the process that he are opting, whatever area, whatever zone which is a part of this manufacturing product, anything which is involved in the manufacturing of this shaft, whether it is the material which this manufacturer is purchasing from a vendor, whether the machine with the help of which it is obtaining the shaft, whether the labor with the help of whom he is developing the shaft, whether the storehouse where he is keeping the shafts, any place, anywhere, anything which is related to the shaft, everything must be supervised, so that every manufactured product must fall in this range and can provide the manufacturer maximum profit, best quality. That, my friend, will be called as quality control. The standard defined was 24 to 26. So this manufacturer must produce the shafts in this range. Then only he can say he has attained the quality that was expected out of him. I hope you people are getting my point. I hope you people are getting my point. Right? Guys, if you have any doubt up until now, or if you want me to proceed in a faster way, please write it in the comment box. Right? Please write in the comment box. Because I know exam is very near and you might even want a shorter way to end this topic. So if you would like me to do that, please say a yes or no. I will do according to you guys. Okay, so guys, now, for this inspection, my friends, for this quality control, so that 50,000 shafts are manufactured in this range, what we make use of is control chart, right? I will get back to the slides that I have skipped, right? So what is used in industries is a control chart. With the help of control chart, we basically supervise or scrutinize, analyze the entire manufacturing process, so that 50,000 shafts can be manufactured in that range. I hope you are getting my point. So control chart is what? The control chart is a graph used to study how a process changes over time. Remember how a process changes over time. Suppose you have a manufacturing setup whereby the help of a hammer and a die, you are producing these shafts, right? Now, my friends, these are machines. On constant operation, on constant working, these machines, they get wear and tear. These machines, they develop a lot of vibrations. There are hundreds of factors which can affect the functioning of these machines. So if the process, it changes over time, control chart is basically a graph which can study that change in process, right? Data are plotted in time order. What is the data? The data is basically the dimensions of these shafts. The dimensions of these shafts, my friend. Like if I am keeping in record that the shafts that I am making have a diameter of 25.2, 25.4, 24.6, 24, 26. So I am basically keeping the record of the data. So I am plotting this data with respect to time. Okay, so control chart is basically the plot of data that we have, the dimensions that we want to check with respect to time, so that we can understand the change in the process that has happened. A control chart always has a center line. So remember, a control chart will always have a center line for the average, an upper line for the upper control limit and a lower line for the lower control limit. So guys, here I will give you a brief idea about the visualization of the control chart. So control chart will have a central line, it will have a upper control limit, it will have a lower control limit. What will be the meaning of this? I will explain that to you in a moment's time, but do not even think for advice that I will leave anything. Okay? Now, lines are determined from historical data, right? Historical data means whatever the shaft that have already been produced, it has become history. So these lines, like these lines, central line, upper control line, lower control line, are determined through historical data. By comparing current data to these lines, you can draw conclusions about whether the process variation is consistent, in control, or is unpredictable, out of control, affected by special cases of variation. Guys, so basically with the help of these datas, we plot the control chart, which is what? A plot of time and data, and through this we plot three lines: control line, upper control limit, lower control limit. So central line, upper control limit, lower control limit, this will basically help me to determine whether my process is consistent, that in control, whether the range that Tata Motors have given me 24 to 26, whether the shafts are producing in this range or not. Control chart will help me to realize this. I hope people are getting my point. So whether my process is consistent, in control or not, or is unpredictable, out of control, that can be achieved with the help of a control chart. I hope you people are getting my point, Baba. I hope you people are getting my point, Baba. If yes, give me a yes at least. Give me a yes at least. Now, when to use a control chart? When to use a control chart? Controlling ongoing process by finding and correcting problems as they occur. So how control chart will help us? Tata Motors have asked us to manufacture shaft in this range. We have created a setup, a facility, with the help of which we are producing shafts in this range. Now this control chart will basically keep a record, a track of data with respect to time. Every shaft that is getting produced, we will take the dimensions of that shaft and plot the control line, central line, control chart. So if I keep on plotting the control chart, listen to me very carefully. No, Ashwin, I can see your comments. So control chart will basically help me finding the problems. If the shafts are getting out of this range, then control chart will basically tell me, guide me that the process is not going butter smooth. You have to correct the problems that are occurring in the process. Predicting the expected range of outcomes from a process. With the help of control chart, you can basically find that the products that you are producing will be in what range. Range means I can get an idea that if Tata Motors want the shafts in this range, then my shafts are like 24.5 to 25.5. I hope you people are getting my point. I hope you people are getting my point. It can help me predict the expected range. Determining whether a process is stable, I have already told you this. Analyzing patterns of process variation from special causes, non-routine events or common causes built into process. Array, suppose guys, for producing these shafts, we were buying the basic material from some vendor, and that vendor stopped producing, stopped manufacturing. He went out of business. Now we went to some other vendor in order to produce these shafts for Tata Motors. Now the new vendor is basically a non-routine event. Something new has happened in the process. Now due to this new vendor, the manufacturing might get changed. The dimensions that we will be achieving will be varying because the vendor must be supplying a product which might be a bit different with respect to the previous vendor. I hope you are getting my point. So any kind of variation taking place, control chart will basically analyze that for us and will help us to resolve the issue so that manufacturing can go on smoothly and we can produce shafts in this range provided by Tata Motors. Determining whether the quality improvement project should aim to prevent specific problems or to make fundamental changes to the process. That means determining whether the quality improvement project should aim to prevent specific problems or to make fundamental changes. What is the meaning of this? Control chart will help us to basically understand that whether we need to completely overhaul the process, completely redesign the manufacturing process, or we can make some fundamental changes to the process and my job can be done. All we need is shafts in this range 24 to 26 so that this can happen. Whether we need a complete change in the process or whether we need a complete new process. I hope you are getting my point. I hope you all are getting my point, right? So guys, now I have basically discussed the very basics of control chart. Very basics of control chart. Now, let us focus. Let us focus. Let us get into that area from where in gate examination questions will be asked. Right? So guys, I have already explained you guys standard normal distribution. I have already explained you what is standard normal distribution in the PERT CPM chapter. Let me cover that once again. So standard normal distribution, the word normal distribution, what is meaning of this? What is the meaning of this? Right. So if I tell you very honestly, this normal distribution applies in like 99.99% of events that are happening around us. Anything that is happening around us, the normal distribution concept says it has a specific pattern. Everything is happening with the help of a pattern, right? I gave you an example when I taught you PERT CPM, that Virat Kohli example. I hope you guys remember, right? I hope you guys remember. So, what is the concept of normal distribution? What is the concept of normal distribution? Normal distribution says that let's say if Virat Kohli has a batting average of 55 runs. Virat Kohli has a batting average of 55 runs. Now what happens, my friend, if we consider Virat Kohli's score to follow normal distribution, then basically this 55 or average value will become the center line, 55 average. And for here, Z is equal to 0. Now what is Z? If you have seen the normal distribution function, you would know that what is the Z, right? So guys, at 55 or at mean, the value of Z is basically 0. Now, what it says that at 0, at 55, the probability of this event is 50-50. The probability of this event is 50-50. Now, what is the meaning of this? Now, let's say somebody says that Virat Kohli has a batting average of 55 runs, and if Virat Kohli has went on to bat today, आज विराट कोहली बैटिंग करने गया, he has went on to bat today. Now, if somebody will ask you, कोई आपसे पूछता है कि how much विराट कोहली will score in today's match, आज के मैच में विराट कोहली कितना बनाएगा? Guys, the basic answer is that you don't know. You don't know आज विराट कोहली कितना बनाएगा. अरे विराट कोहली तो जीरो से लेके कितना भी कहीं तक भी बना सकता है. He can score anywhere from zero to a double century or a triple century. I hope you are getting my point. But if somebody will ask you one question, will Virat Kohli score 55 runs? His batting average is 55. Will Virat Kohli score 55 runs today? You know what you will say? He may, he might not. He may or he may not. So the chances, the possibility, the probability that Virat Kohli will score 55 runs today is basically 50-50. Either he will score 55 or he will not score 55. So with respect to the mean value of 55, if I have considered the batting score of Virat Kohli to follow normal distribution, then my friends 55 runs will be considered as the mean or the average value, and this will basically has the highest probability. I hope you people are getting my point. I hope you people are getting my point. I hope you people are getting my point. All the other events, whether it is this event, which is more than 55, less than 55, my friends, they will not have a better accuracy or better probability with respect to the mean value. I hope you are getting my point. I hope you people have understood what is normal distribution. Right? So this same normal distribution is basically used for quality control. This same normal distribution is used for quality control. How? I will show you that. It basically says that if Tata Motors are asking you to produce a shaft of diameter 25 centimeter. Consider this 25 centimeter to be the mean value, to be the average value. But remember, Tata Motors have given us a range 24 to 26 centimeter. So my friends, what I will do, I will consider this range here on this graph. I will consider this range 24 to 26. Now this is because this is a design specification. So this curve will be a design curve. This curve will be a design curve. Where this, my friend, is going to be the lower specification limit, and this is going to be the upper specification limit. I hope you people are getting my point. I have to ensure that I develop shafts in this range. Now guys, I started producing shafts. I started noticing down the dimensions of shaft: 24.5, 24.8, 25.2, 25.7, 25.9, 24.3. Some are, let's say, 24. Let us delete 24. Let's not consider that. So guys, if I will basically average these values, let me just do that with the help of my good old calculator. Where have I kept it? Okay, here it is. So if I take on the average of this, so it is coming out as 25.06. Let me use another color for this. It is coming out as 25.06. if I draw the normal distribution curve, I am basically getting that the highest value that I am achieving. Arey yaar, I forget every time that I have not selected the proper tool, right? And the minimum is 24.3. So basically, the minimum value that I am getting is this, and the maximum that I am getting is this. So this is 24.3, this is 24.9. So guys, unless and until this manufacturing curve or production curve, right, is well within the limits of 24 and 26, everything is fine. Everything is fine. I hope you are getting my point. This blue graph that I have drawn here, it has a mean of 25.09. I have calculated that with the help of these data that I have, right? The shafts that I am producing. Now this 25.09 mean, although the company wanted me that a mean should be 25, but if my mean is 25.09 and my shafts are well within the limits that the company wants, I have no issues. I have no issues. But guys, if I will get an idea that my mean is shifting, if I will get an idea that my mean is shifting, and you can see that due to the shifting of the mean towards the right hand side, this 25.9, that is the upper limit of the manufacturing curve, is very close to the upper limit of the design curve or the upper specification limit. Now what happens that if this keeps on going on, if this mean keeps on shifting, if this mean keeps on increasing, there is a very good chance that I might get outside this upper specification limit and might start producing shafts which will not be accepted by Tata Motors. So guys, basically the area of this zone, the area that is outside the red limits, that is outside the lower specification limit and the upper specification limit, is basically the rejected lot. We will have to make sure that we are well within the boundaries of this. So my friends, because these are the last sections, I do not want to cross this. I want to remain well within these limits. So I have my own lower control limit and upper control limit. We have our own lower control limit and upper control limit. We will make sure that we do not pass this upper lower control limit zone so that manufacturing can keep on happening in this range and everything goes smoothly. So guys, just now that how I have checked using these data, I have drawn a normal distribution graph, a normal distribution curve, and on the basis of this I have verified that whether I am well within the limits or not. And if I am, then my quality is under control, and if I am not, it is getting out of control. I will have to check the parameters that are responsible for these and have to correct them. I hope you are getting my point. So guys, with the help of this normal distribution curve, we will basically be looking into the control charts. How the control charts are functioning, and let me tell you, the concept of normal distribution, my friends, is the very basis of the control chart. I hope you have understood the control normal distribution concept. Otherwise, the control chart you will not be able to understand. Correct? I hope you are getting my point. Now, whenever we get a normal distribution curve, things like mean, that is represented by x bar. So this mean 25 centimeter is x bar, or this 25.09 is x bar for this curve, right? So there are two curves that I have drawn. One is the design curve, one is the manufacturing curve. So x bar is basically the average, my friends. Okay. One more thing that you will get to hear in the normal distribution is standard deviation sigma. So standard deviation is root over variance, or there is one more relation which you will realistically be seeing, that is summation of x minus x bar whole square upon n minus 1 root, right? So this inside value is basically the variance and this root over is the standard deviation. I am not going deep into this. These are the basic formulas of standard deviation and average or variance that we have studied in class 11th under the statistics chapter. So I am basically revising you that these are the formulas where x is basically this value, that's a 24.3, x bar is the average value 25.09, n is the number of readings that I have taken, 1, 2, 3, 4, 5 and 6 readings. I hope you are getting my point, right? Don't worry, I will explain these things very nicely so that you guys can be able to solve the questions, right? Now guys, there is one more thing that we should discuss before we proceed. There is a concept of Six Sigma. What is this Six Sigma process? Basically, this is a quality control standard. This is a quality control standard. Now, what is the meaning of the word standard? Which has been set as a benchmark, which has been set as a parameter, right? Because the thing is that if we keep on drawing these normal distribution curves, if we keep on drawing these normal distribution curves again and again, so basically what will happen, in order to provide the proper specifications that how we are working, what are the limits that we are working on, right? I mean, if Tata Motors has given us a range from 25 to 26 and we have a mean of 25, but I started producing, I am started getting these datas, and with the help of this I draw this curve, which is my manufacturing curve, right? Now this manufacturing curve, this also has a limit, that is the lower control limit and the upper control limit. Okay, so this upper and the lower control limit will have a range, and this range, my friend, is defined in terms of z into sigma, where z is basically a confidence factor. The z is nothing but a confidence factor. I mean, when I taught you work study, I gave you one question where I took the value of this z as 2 for 95%, 3 for 99.73%, 1 for 67%. I hope you are getting my point, right? So this z into sigma, where sigma is basically the standard deviation, and then z will have a multiplying factor like 2, 3, 4, 5, 6, for which we will basically be increasing this range. The greater the value of z, the greater will be this range, right? So this range is basically the control limit range, where there is a gap between the lower and the upper control limit, and if we are working in this range, then we are basically defining that what are our quality standards. I hope I will be able to explain this. Just wait for a second, right? As you can see here in this graph, I have taken this graph from the internet. Let me just zoom this for you. So guys, check this out, Sapra Manthan. Sir, is this the detailed score for GATE and ESE or just crash course? Sapra, let me just tell you straight away. I started this as a crash course, but basically I covered everything that is in industrial engineering and operations research. So it has basically become a full course. And today is the last lecture in this. I will be starting a very short revision formula based course from 7th of January. Basically, you have asked me so that I have to answer this question, otherwise I would have told this at the end of this class. So guys, you can see here that if the deviation is just sigma, यहाँ पे minus sigma and we have plus sigma here. So for deviation of 1 sigma, 68.27% is basically the area inside the curve. This area inside the curve for plus minus 1 sigma is 68.27%, right? So what happens? As a general standard taken, it is observed that out of million parts, like if somebody is manufacturing 1 million parts, and 1 million, 10 lakh parts. If somebody is manufacturing 10 lakh parts, then out of those 10 lakh parts, 3,17,300 are found defective in general, right? So if somebody says that I am following sigma manufacturing process, sigma quality control, that means that around 32% of the shafts or 32% of the manufactured products are defective. So that signifies a very poor quality standard. If somebody says that we are looking for 2 sigma, we have a quality standard as per 2 sigma, so that covers 95.45%. 2 sigma means I go 2 sigma here, 2 sigma here. So this will basically become plus sigma, this will again minus sigma, and this total range, my friend, is minus 2 sigma, and this total range is basically plus 2 sigma. I hope you are getting my point. Shreya Shukla, hi. Hi Shreya. This is the first time I am finding you live. Do you watch my lectures recorded? So, if I go to 2 sigma, if I cover this much area, entire area inside the 2 sigma range, then basically it signifies that out of every 1 million parts, 45,500 parts are defective. But if I go a little bit higher, 3 sigma, the standard, then 99.73% parts are well within the standards, and this basically gives us 2700 parts per million defectives. So imagine 10 lakh parts are produced, and out of those 10 lakhs only 2700 parts are found defective. So 3 sigma is a very general or basic standard. This is considered good quality control. This is considered good quality control, right? This is considered good quality control. So good quality control for plus minus 3 sigma, good quality control for plus minus 3 sigma basically gives us a range of 6 sigma. Guys, please mark my word. I am not using the word 6 sigma. I am using the word range of 6 sigma, right? Range of 6 sigma. So range of 6 sigma means from minus 3 sigma to plus 3 sigma. I have basically a range of 6 sigma, and this is not 6 sigma process. Range of 6 sigma is different. This is not 6 sigma process. 3 sigma is basically considered as good quality, a standard quality, if nothing else is given in the question. If nothing else is given in question, then always remember Z will be equal to 3. In this area, in this portion where I have explained, in this area where I have explained this Z sigma, Z into sigma. So if nothing is given to you, then basically, my friend, this Z is 3. If nothing is given in the question, always consider Z as 3 or the range to be of 6 sigma. But if it is asked in the question that use 4 sigma, 5 sigma, 6 sigma, then you will have to use this. Then it means that you go full beyond minus 6 to plus 6 with a full range of 12 sigma. With a full range of 12 sigma, I hope you are getting my point. So guys, if somebody goes to 6 sigma, then my friends, 99.999966% area is covered. Remember, 100% area can never be covered because this graph is exponential. It will never ever cut this axis. So 100% area will never be covered. But if I am considering this much large range, 6 sigma, then 99.999966% gets covered, which basically means that only 3 to 4 parts per million, 3.4 parts per million are defective. You are producing 10 lakh shafts, and out of those 10 lakh, only 3.4 shafts are found defective. So you can imagine the quality standard of this. Six Sigma. So this Six Sigma is a very popular process now. The Six Sigma, which is basically a range of 12 Sigma. Remember, range of Six Sigma is different. Six Sigma process is different. Six Sigma means plus minus Six Sigma, range of 12 Sigma. I hope you are getting my point, right? People always get confused in this. A question appeared in the GATE examination. There are many of the students made mistake in this. Right, so Six Sigma process basically covers the entire plus minus Six Sigma range, 99.9996% of the area of the standard normal distribution curve. This process was first coined by Toyota company. The Japanese company Toyota was the first who ever introduced this much quality standard. I don't know whether you know this or not. I mean, if you must have seen all the taxis that are running out there, they are basically Toyota Innova. Toyota company makes very less cars in India because they don't find the Indian market to be very suitable. The Indian customers basically want a BMW car under 10 lakh rupees. So Toyota do not deliver that. Toyota is the number one automobile manufacturer in the entire world, my friend. Okay, and they have basically reached to that spot by providing the best quality product. Toyota Innova, people run that car for like 10 lakh kilometers. I mean, you can't even imagine a Hyundai, let alone say Hyundai, take a Honda car. Those cars even will not go 10 lakh kilometers. Hyundai cars, they fall apart around 1 lakh kilometers. Honda cars, they fall apart on 2 lakh kilometers. But Toyota Innova, benchmark, man, benchmark. It goes like 5 lakh, 7 lakh kilometers. The people, those who are running that on taxi, ask them. Yes, Jitendra Sahu is right. So Six Sigma process is basically the pinnacle of the quality standard. There are processes even better than this. 7 Sigma, 8 Sigma, 10 Sigma. But that we are talking about Rolls Royce and Bentley. They are out of our budget. By keeping the quality standards, providing the product in budget. Sir, you made me understand industry in a better manner. Thank you so much, sir. I used to watch all your recorded videos. Thank you, sir. Thank you, Shanmuga Shankar. Thank you very much. Words like this basically motivates educators like me to provide you with even better content, right? So, I hope you people have understood what is the meaning of this sigma and everything. Sir, what about bullet? Shreya Shukla is asking, what about bullet? Bullet means that bullets that you put inside the gun or the Royal Enfield motorcycle bullet, or you have something else as bullet. So she has retracted her message. I don't need to retract your message, my friend. So I don't know about bullets, right? I mean, Royal Enfields, they look good, but they are not reliable. I would still say that they have a long way to go in terms of quality and everything. They look very good, but sir, she cheats me. कहती थी कभी धोखा नहीं देगी. What to do? अच्छा. Ahan Shah is basically looking for a what do you say? A relational advice from me on this session. Sorry, Ahan, can't help you. In this area, I am weak, my friend. So let us move on. 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 So now types of control charts. Now I have basically explained you everything. You must have understood the words like normal distribution curve. You know what is upper specification limit. You know what is lower specification limit. You know what is upper control limit. You know what is lower control limit. I have told you all those things. The little things, sigma, 3 sigma, 6 sigma, I have explained you. Now, types of control chart. Types of control chart. Types of control chart. ए भाई आहान पढ़ाई लिखाई पे ध्यान दे भैया, करियर बना ले, बंदियां पीछे भागेंगी तेरे, इन चक्करों में पड़ा रहेगा ना, रोने धोने से कुछ नहीं होता जिंदगी में. Sorry for a bit of Hindi, my friends, but my friend needed advice. So types of control chart. So guys, there are two types of control chart. One is called as the variable control chart. Other one is called as the attribute control chart. What is the meaning of variable attribute? So variable data are measured on a continuous scale. So this is very important. Continuous scale, है ना? Continuous scale. अरे no need to say sorry. No need to say sorry. For example, time, weight, distance, temperature. I mean, if I talk about time, somebody will tell me it is 1:15, somebody will tell me it is 1:15 and 30 seconds. If I talk about distance, some will give me 1.6 kilometers, some will give me 1.63 kilometer. I hope you are getting my point. If I talk about temperature, then we record temperature in 36.9 degree centigrade. So भाई प्यार में धोखा है, पढ़ लो यही है मौका. Very nice, Shreya. Very nice. So, guys, listen to this. Those data which can be, which is basically measured continuously, not with break. Like those data which is continuous data, they are basically analyzed using those control charts which are variable control charts, where the data is on a continuous scale. Like we cover even the smallest of the decimals also. Now, this data, to analyze this data, we need a continuous distribution function. So guys, remember, the variable control charts will basically work on the concept of normal distribution. Will work on the concept of normal distribution, right? Now, what is this normal distribution? I have already explained you. This curve, my friend, the normal distribution curve is a continuous curve without any break, right? So without any break, so those data which are without any break cover each and every small decimal points. Those are scrutinized or analyzed using the continuous distribution function, which is a normal distribution function, right? So in terms of variable charts, we have to study two charts: X bar chart, R chart. Now I have to write this as X bar, right? X bar chart is also known as mean chart, and R chart is also known as range chart. So I have already explained you what is mean. This value is the mean. I have already explained you what is range. This is our range, right? The difference between the upper and the lower limit is the range. The mean is the mean, the average. So remember, both of these follow normal distribution. Now this is X bar chart is important for GATE exam. Is important for GATE exam. But this normal R chart or range chart is not that important for GATE exam. I will tell you why this is not that important for GATE exam. ठीक है ना? But up until this point, just remember that variable charts are basically for those where we are having such domain where we can measure. I mean, we can measure time, we can measure weight, we can measure distance, we can measure temperature. So anything which is a variable, which varies, which can be measured, continuous curve is required, continuous distribution is required. So this is basically based on the concept of normal distribution. Now I hope you are getting by the point variable control chart. Now what is the meaning of attribute control chart? Attribute means what, my friends? Attributes means चाल चलन. चाल चलन, those who know Hindi. चाल चलन. Character. Attributes means when we are looking for character. So attribute data are counted and cannot have fractions or decimal. So we are talking that there should not be any fraction or decimal. So not fraction, decimal means only integer will there. Shreya, okay, don't worry. I will tell you attribute chart, then you will be able to compare the both. ठीक है ना? I am saying fractions will not be here. Why fractions will not be here? Attribute data arise when you are determining only the presence or absence of something. When I am only concerned about the presence or the absence, either yes or no, success or failure, accept or reject, correct or not correct. हाँ या ना? Yes or no? Then my friends, I am looking for attribute, character. Ahan, please don't make me block you, my friend. I am very lenient in all these things, but please don't make me block, right? I have seen Shreya's comment. Please don't make me block you. And please stop commenting like this. Okay? All I am saying is, when we want to check something, like suppose we are producing a shaft. हाँ यस अंकुर, प्रोडक्शन में मैंने न्यूमेरिकल्स कराए हैं उस सीरीज में, प्रोडक्शन में मैंने न्यूमेरिकल्स कराए हैं उस सीरीज में, राइट। अनिरुद्ध जागीरदार, सर ये सब गेट में है क्या सर? अरे हाँ भैया बिल्कुल है, बिल्कुल है गेट में, इट इज डेफिनेटली इन गेट एग्जामिनेशन, राइट, एंड वेरी इंपॉर्टेंट ऑल्सो. Up until 2017 I didn't used to cover these topics, and in 2018 paper one question came from the capability index. Okay, so so Anirudh, is your question answered? Anirudh, is your question answered? Okay, so let me move on. So guys, whenever we want to check some characters, right, suppose we have a shaft, right. Now this shaft has a diameter of 25 centimeter. Okay, let me just take a new page so that I can explain this to you guys properly. Suppose I have a shaft, right, and Tata Motors have basically given us a mean diameter of 25 centimeter. Now they have provided us a range from 24 to 26, and they want 50,000 shafts. 50,000 shafts. So what basically happens? सर इससे कम आता है बहुत एग्जाम में. Sir, characters means as we behave. Yes, Shreya, you are right. Ankur, it is true, my friend, that very little has been asked from this domain in the GATE examination, but it does not mean that as an educator or a teacher I should skip. Right? I hope you get my point. I mean, as a student, it is your choice, your liberty, that you can select which topics you want to study and which topics you want to avoid. But as an educator, my friend, I have to cover everything, right? I hope you get my point. Because this is a complete course on industrial and OR. That's why I am covering everything. So please, right? So 24 to 26 is the range provided by Tata Motors. 25 is the mean. Correct? I hope you are getting my point. So what Tata Motors can do, I mean, if you have studied metrology and inspection, they will produce two rings. One ring will be of 24 centimeter, one will be of 26 centimeter. And now what they do, they take shafts from samples, like these 50,000 shafts are there, they will divide these shafts in like 50 into 1000, like 50 groups having 1000 samples of each. Yeah. And they will just select this 1000 sample and will start using these rings and make sure that these shafts are passed through these rings. Now if a shaft passes through the 24 centimeter ring, then basically that shaft will have a lesser diameter than 24. I hope you are getting my point. If the shaft passes through the 24 centimeter ring, then the shaft will have a lesser diameter than 24. And if the shaft will not pass through the bigger ring, that shaft will have a greater diameter than 26. So all those shafts need to be rejected. That's why, my friend, this small ring is called as a no-go ring, and this big ring is called as a go ring. So shafts should pass through this 26 centimeter. Shafts should pass through this 26 centimeter and should not pass through this 24 centimeter. I hope you are getting my point, right? So now, my friends, let me just explain this to you. If through the vernier caliper or through some measuring gauge, if I keep on measuring the diameter of each shaft, like 24.5, 24.9, 25.7, 23.2, if I keep on measuring these values with the help of a measuring instrument like a vernier caliper or some gauge, screw gauge or anything, then these are basically variables, my friend. These are basically variables which can be measured. Distance can be measured, length can be measured using a measuring instrument. But if I am concerned about 24 to 26 only, I do not want to know the dimensions of each and every shaft. I am just concerned about whether it is in this range or not. I can just select, make these rings, make these no-go and go gauges. Sir, so you are best because you explain everything, you answer every question. Thank you, Shreya. Now listen. All I am saying is that if we make a no-go gauge and a go gauge, now what happens? We do not have to measure anything. We do not have to measure anything. We are just looking for an attribute, a character, that whether it goes through the no-go or not, whether it goes through the go or not. I hope you are getting my point. So it is rejection or acceptance based on one attribute, that whether it goes through the go and no goes through the no go. I hope people are getting my point. I hope you people are getting my point. Right. Now, my friends. Now. I hope you have understood what is the meaning of attribute. I hope you have understood what is the meaning of variable. Right. So anywhere if they are talking about variables, remember we must use the X bar or the R chart. Anywhere if they will talk about the attributes, we have four options. Either the P chart, the NP chart, the C chart and the U chart. Now what are these charts? What are these charts? है ना? Let me just discuss. Let me just discuss what are these charts. ठीक है ना? Guys, these are control charts. You already know control charts are what? They will have a upper limit or lower limit, so that we can check that whether the manufacturing that we are doing. I don't know where is Ahan. Don't feel upset, my friend. Don't feel upset. Right? So, all I'm saying is, where was I? If we are considering variables, then we will be using X bar and the R chart. How we will use that, I will explain to you guys. And guys, if we are talking about attribute, we will be using these four charts. Now let us just discuss these charts one by one. Let us just discuss these charts one by one. Now let us first talk about X bar chart and R chart. X bar chart is called as the mean chart and normal distribution is going to be used. R chart is the range chart, again normal distribution is going to be used. Now some notations are there. UCL is the upper control limit. I will be writing the short forms. So I am already explaining this to you. I will be explaining this to you. LCL, my friend, is lower control limit. CL is the center line. N, my friend, will be sample size. PCR is process capability ratio. In gate 1 question was asked from this. Sigma dash is process mean standard deviation. X bar is average of measurement. X double bar, this is X double bar, right? Average of averages. R is the range. R bar is the average of range. USL is the upper specification limit. LSL is the lower specification limit. So I am already notifying everything whose short form will be used later on. Don't worry, when I will use the short form, I will again come back to this page and will remind you that this is this. Okay. Now my friends, now in the X bar chart, in the X bar chart, this center line is basically the X bar. Center line is basically the X bar, and this is the array yaar, lower control limit, upper control limit. Now this, my friend, minus 3 sigma x, 3 sigma x. सर इतना स्लो मत बोलिए वरना मैं सो जाऊंगी. Okay. Sorry for that. So the center line, my friend, this is the center line or the X bar. This is the lower control limit, this is the upper control limit, this is minus 3 sigma x, this is plus 3 sigma x. So if I will write the lower control limit, so this will be x bar minus 3 sigma x, upper control limit will be x bar plus 3 sigma x, and sigma x is equal to sigma dash by root over n. So guys, let me just tell you straight away, any question they will ask, the objective will always be to find the upper limit and the lower limit based on the deviations, right? So I have already explained you that x bar, my friend, is the average of measurements, CL is the center line, UCL upper control, LCL lower control limit. N is the sample size, right? So this N here is the sample size. What is this N will be? I will explain everything with the help of one question. But I have just written the X bar chart here right now. Right? This sigma dash is the process mean standard deviation. And sigma x is the process standard deviation. Okay? So let us take one question for this so that we can construct an X bar chart. A quality control inspector at the XYZ company has taken 3 samples. This is important. 3 samples with 4 observations each. 3 samples are taken with 4 observations each of the volume of bottles filled. So guys, remember, volume is a measuring quantity. Volume can be measured. So we are using a variable chart, that is the X bar chart. If the standard deviation of the bottling operation is 0.2 ounce, so they have given us the standard deviation 0.2. So sigma is given to us as 0.2, right? Sigma is given to us as 0.2, and they have given 3 samples with 4 observations. Good night, Shreya. 3 samples with 4 observations. So guys, as I told you, small n the sample size, small n the sample size. So sample size, my friend, sample size is 4. Sample size is 4 observation. So n, small n is 4. The size of the sample, 4 observations in one sample. We have taken 3 samples. So 3 into 4, 12 readings have been taken. Use the below data to develop control charts with limits of 3 standard deviation. This 3Z. Standard deviation 3Z. I hope you are getting my point. For the 16 ounce bottling operation. Right. So now see. Observation 2, 3, 4. 4 readings on 3 samples. So the first sample they have taken, they have measured the volumes as 15.8, 16, 15.8, 15.9. Correct? Again they have taken one sample, 16.1, 16, 15.8, 15.9. Again they have taken one sample, 4 observations in each of these. I hope you are getting my point. Now what I have done, I have calculated the average of these. These averages are called as X bar, right? So guys, X bar here, average of measurements, X bar is the average of measurements. So I have taken the averages of these values. This is the average, right? These are the averages. I hope you are getting my point. Now guys, now my friends, center line and the control limit formulas for the X bar chart. Center line formula, X double bar, averages of averages, So X bar is, this is X1, this is X2, this is X3. So I will simply put X1, X2, X3 here, divide this by K, the number of samples. So number of samples we have is 3. Sigma x is equal to sigma dash by root over n. sigma dash by root over n, where n is the number of observations in each sample. They have already given us in the question sigma point to n equal to 4. So we will put the value 0.2 divided by root over 4. I will get sigma x, right? I will get sigma x. Now guys, what is sigma x? It is the standard deviation of process. Standard deviation of process. What is sigma? It is the standard deviation of process mean, right? Standard deviation of process mean. This you must understood. ठीक है ना? So upper control limit, as I have already told you, x double bar plus z into sigma x. Here, let me make it double bar. X double bar plus minus 3 sigma x. So this is general. I have taken z equal to 3. I have taken z equal to 3. In this question, it is giving you that z is equal to 3, right? So using these friends, I have calculated this for you, that x double bar is 15.92. So this is the center line. Center line. Upper control limit we have calculated using the formula 15.923. In case of sigma x, I have written 0.2 by root over 4. So this is 16.22 and this is 15.62. So guys, now please check how the x bar chart is made, x bar control chart. So this here, my friend, is the center line, that is 15.92, right? 16.22 the upper control limit. So this here is 16.22 and this last here is 15.62. Come on here. 15.62. Somewhere here. 16.22 will be above this, but just consider this. Okay, na? So guys, this is basically the upper control line, lower control line. This is the upper control line. Upper control line, lower control line. So guys, if the values that we are getting, these are the values 15.8, 16. So the minimum you can see, the minimum out of these, the minimum of these you can see. Let me just erase everything so that it becomes clear to you. The minimum of these values you can see is 15.8 and the maximum you can see is 16.1, right? So if minimum is 15.8, maximum is 16.1 and they are well within these limits, my friend, then this is a controlled manufacturing. This we call as controlled manufacturing. I hope you are getting my point. If the bottles, volume in the bottles, the points that I am marking are well within these limits, the upper control limit and the lower control limit, then my friends, I would say that the manufacturing is well under control. We are manufacturing well within the limits and everything that we are producing is going to be accepted. Now suppose what happens, suppose on manufacturing you see what, some points are going like this, like you can see, let's say this is 0.1, 0.2, this is 0.3, 4, 5. Suppose instead of these 3, 4, 5, our 3, 4, 5 will be like this, 3, 4 and 5 is going outside, right? So this means what? That we have crossed the upper control limit. We have crossed the upper control limit and this means that this particular product, bottle with water or volume, is going to be rejected. I hope you are getting my point. So if we find a couple of points showing a increasing trend, then my friend, we must make sure that something has gone wrong. In the manufacturing process, something has gone wrong. We have to analyze the manufacturing process. We will have to check the factors which are responsible for the volume of the fluid inside the water bottles. We will have to check each and everything in the process and make sure that these points go backward towards these lines, towards the center line, towards the line that we have achieved, so that the manufacturing is well under controlled and nothing is manufactured beyond these limits. So this is the reason why control charts are used. This is the reason, my friends, why control charts are used. Just give me a yes or no. If you have understood this, just write a yes in the comment box, and no if you have not. If you have understood the very basics of this, then please give me a yes. And if not, then please write no. I will explain once again. Come on, guys. Oh, Shreya, I thought you went to sleep. You bid us good night. So, what about others? Clear? Okay, nice. Ashwin has also understood. So, guys, that's really nice that you have understood this concept. That's really nice that you have understood. Now, guys, let's talk about range, right? Let's talk about the range. So, you can see I have written sample ranges here. Sample ranges. What is the meaning of this? Now, the sample that we have taken, the sample number 1, in this sample, 15.8 is the lower limit and 16 is the upper limit. So, basically, the range is 0.2. In this sample 15.8, 16.1, the range is 0.3. Similarly, here the range is 0.2. Right? Okay. Okay, now see this. Now see this, my friends. See this. The center line and the control limit formula for R chart or range chart. So the range chart, the upper control limit is given by the formula D4 into R. Let me just write this here. The upper control limit is given by the formula D4 R bar, and the lower control limit is given by the relation D3 R bar. Now what is this R bar here? R bar, my friends, is the average of range. So we have ranges from sample 0.2, 0.3, 0.2, 0.2, 0.3, 0.2. So we have basically used this and calculated the average R bar, that is 0.233. Now this R bar needs to be multiplied by these factors D4, D3 in order to get these values. Now what is D4, D3? Now guys, that's why I said that R bar questions will not be asked in GATE examination. This is not important with respect to GATE because they will have to give you this table. Without this table, we cannot find the upper and the lower control limits of R chart, right? So what is the meaning of this? Like the sample size that we have taken, in this sample we have taken 4 observations. So 4 observations in one sample is there, right? I mean overall we have taken 12 observations, 4 into 3, 12 observations, but we divided that in 3 samples having 4 observations each. So it simply says that you find the size of the sample, that is n. So remember n was 4, we have 4 observations in each sample. We have 4 observations in each sample, and from this 4, my friend, we can find D3 and D4 corresponding to 4, that is 0.00 and 2.28. So 0.0 multiplied here D3 and 2.28 multiplied here, we got the upper control limit and the lower control limit of the range. Now remember, these are range, right? These are range. The distance, gap between the upper limit and the lower limit. So this range will always be either 0 or positive. This range, my friend, will either be 0 or positive because it is the difference from the upper and the lower limit. I hope you are getting my point. This range, it cannot be negative, right? So if we draw the R chart, there will be a center line, which will basically signifies the lower control limit, and there will be a upper line which is going to be upper control limit for range. So the range here is 0 and the range, my friend, on the upper side is 0.53. Okay. So whatever samples we keep on taking, these are the ranges 0.2, 0.3, 0.2. So let me just mark this 0.2, 0.3, 0.2. So this is basically the range chart, and unless and until the range is well between the upper and the lower control limits, everything is fine, everything is well under control, nothing wrong is happening, every product that we are making is bound to sell. I hope you people are getting my point. Right? So guys, that's it. That is the end of X bar R chart. One more thing, the process capability index is left. है ना? I will explain this to you guys in the next class because time is over here. So guys, as I was saying that this topic is left process capability index, but time is over. So I will discuss this in tomorrow's class, which is going to be the last class for quality control, where we will basically be solving some questions and we will be looking into P chart, NP chart, C chart. So today class be like this. Ashwin, what do you mean by this? So guys, in the next class we will be solving questions on the rest of the charts, right? So same time, 9:15 p.m. Same time tomorrow. Okay. So guys, that's end for today's session. Let me do the basics. Right? As you guys have already been informed multiple times that Unacademy has started a batch Evolve for GATE 2022 aspirants in English and Hindi. The batch started on 28th of December, and if you want to join this batch, use the referral code M10. Bye everyone. Bye. And another batch by the name of Ascent for GATE 2023 aspirants started on 28th of December. If you want to join this batch, use the referral code M10. Guys, one more thing. Please make these investments on the plus or the iconic subscription. I have used the word investment because remember they will return their value in future. On the plus subscription, my friend, you can watch multiple live classes in English as well as in Hindi. है These type of things will not happen, which is happening on YouTube. So remember, the Unacademy platform is a educational platform, whereas YouTube is an entertainment platform. YouTube is an entertainment platform. People entertain themselves through YouTube, but the plus or the iconic package is strictly for studying, right? So guys, if you can make this investment, please do so, because remember, on the plus subscription you can join multiple batches, you can have doubt solving sessions, you can basically be giving tests every week. On the iconic package, my friend, Unacademy will be providing you with a personal coach who will be helping you to plan your studies, who will be giving you study booster sessions, who will be personally analyzing your test and will letting you know that what are your loopholes, how to cover them. And Unacademy will also be providing you with the preparatory study material. As the plus subscription will cost you 30,250 for the 12 month and 38,500 for the 18 month and 44,000 for the 24 month subscription. But if you want to have a trial, you can also go for the 1 month subscription. And guys, remember, if you do so, use the referral code M10. use the referral code MMM10, you know what will happen? These prices will get discounted by 10%. These prices will get discounted by 10%. So using the code MMM10, basically you can see the prices dropped by 10%. 1 month trial package can cost you 4,950 rupees. This is offer is valid on the iconic package also. On 12 month as well as on 24 month, the prices are 50 to 50 and 74,000. But using the referral code MMM10, the prices drops to 50, 45, 25 and 66, 600. So that is going to be all for this session, my friends. That is going to be all for this session. Thank you all for watching this. Please like, share and subscribe. I'll see you all tomorrow at the same time, that is 9:15 p.m. on YouTube with the continuation of this lecture, where we will be solving numericals on X bar and R chart, and then capability index, and then the three charts P, NP and C chart, numericals on that as well. So bye bye guys, take care, see you all tomorrow.